Okay, this video is just going to be a part 2 of the other video where we had relays being used for defrost control. We had an issue where we couldn't put more than 8 images up here on our smart board. As you can see here, it looks like I have 10 images here. I've added an additional 9340 and an additional time delay. But what we've actually done is we've actually created we just cropped everything from the other day. So long story short, all we're trying to do is just get a little creative here so we can add on to yesterday. I said that on this part 1 video, where we're just using relays for defrost, towards the end, there's a couple things that I see that have flaws. And then I said we can make a couple of changes, and one of those changes was we ran the 24 volt primary through the normally closed relay here on this bottom left corner. And we said that in the event that we're in cool mode, we're getting 24 volts here, so contact 2 and contact 5 are going to be open, so we can't go through a defrost. Now, you really don't need to go through a defrost when you're in cool mode anyways, but we want to make sure, because there's no low ambient temperature controls here, we're just using the defrost sensor. But if that defrost sensor would fail in a closed position, we want to make sure in the middle of July we don't go through a defrost. And the only way to do that is we put it on this relay here, and by doing that, we allowed our relay to energize and cool, and 24 volts not to be able to come over to the sensor or over to the timer, because we don't want it to go through a time defrost either. But the second problem is we put a lot of things in parallel. One of those things we put in parallel was the reversing valve. So when we have the Y call coming up to terminal 1 and 2 here, during the call for defrost, whether it's a time defrost or a forced defrost, that 24 volts will make across both poles, and terminal 3 and terminal 6 will be energized. So that means O will be energized, and O will backfeed back to here, which would have canceled out the entire defrost cycle the way I have this wired up. I don't know if anybody caught that, but what we want to make sure is that we don't sit here and this thing go into a defrost, out of a defrost, and it happens within a second. So like I said, it's like working out a math problem, and the bigger the problem, the longer it takes to work out. So we're having to add a little bit more. So I have an additional time delay and an additional 9340 relay, which will fix that problem. What I'm going to do is I'm going to use white, because typically white doesn't show up very well. I can see it. Students in the classroom can see it, but I don't think it shows up very well on the video. And what I'm going to do is I'm going to go ahead and take this O wire back to about right in here. Let me try that again. Make it nice and clean. And I'm just going to say O comes up, and O lands on terminal 5. And remember, 5 and 4 are actually normally closed when there's not voltage here on the relay. And so I can do that, and then what that does is now I can leave O here. So in the event that I'm in cool mode, 24 volts will be here, right? But in the event that I'm in defrost, I can't have 24 volts here, because when this relay is energized, this contact is open, right? And so what comes first, the chicken or the egg, right? So what comes first, coil voltage or contact voltage? What's going to be faster? Well, obviously, contact voltage is a result of coil voltage. So if I have coil voltage here, then I will have contact. So if there was a race, you wouldn't be able to see it with the naked eye, but there's not a tie here. So I'm going to hit 24 volts here, then this will immediately open, which will kill power here and allow defrost to happen. In that scenario, I'm good to go. That's the only one thing I have to do. Now, I told you I didn't want to mix high voltage and low voltage for safety reasons, but for the purpose of what we're trying to do here is just educate that we need to understand path of electricity, input, output, know our timeline, know our relays a little bit better, so we can better understand how simple our boards are. Because if you look at this, you're probably going, oh my gosh, that's pretty complicated. Well, those boards are a lot easier now, aren't they? You'll never look at that board as your best friend ever again. I mean, that board is a very good thing. So good thing for the manufacturers to give us something that works a lot better than this. I can't go in conjunction with a second timer, and the reason why, if I have a 20-minute run cycle, all right, it has to be a 20-minute consistent. The condenser has not shut off. I have not lost Y. And if I'm in that situation, then I can go into a time defrost. But if you look at what the defrost control circuit boards do, it allows me to lose Y. And because it has 24 volts on there, it's keeping a memory on how many times Y has been energized in between time defrost cycles. I cannot do that. With this technology, that is not going to happen. So I wouldn't put any more than just one defrost time, just one time delay on make here. So I know that if I'm running for 10 minutes in heat mode and my defrost sensor has not initiated a forced defrost, well then obviously after 10 minutes of running, I have lost efficiency because my condenser coil should be frosted up from gathering all that heat up and transferring in the house. It should need to go into a defrost just so I can get more heating capacity through that process. So 10 minutes is good enough. But the moment I go into a time defrost here, right? So there's no 24 volts here, right? Forced can happen. The Y call, right, normally closed, powers here. After 10 minutes, it energizes to this point, comes up, lands 24 volts here, which makes the fan shut off. It breaks O contact, so nothing can cancel it back out because it's in parallel. Comes over here, allows the Y that's sitting on the contactor to come over and energize my reverse valve and energize my heat strip. But what's going to take it out of a defrost? Remember, I've got a condenser fan motor that's not running while I'm in cool mode with a lot of hot gas circulating my condenser coil, and my heat strips are running, which is great, canceling out the cold air. But what's going to pull it out of a defrost cycle? Because remember, over here, this sensor's still open. We called for a time defrost. And so the manufacturers on their circuit boards, they're not going to let this thing run into an indefinite defrost cycle because that can cause other issues. So what I put here is I put an additional 9340 relay and an additional timer, and this is to knock out the defrost cycle. So what we're going to do is we're going to come over and we're going to say the moment we get 24 volts on Y, on 1, it's on 2 already, it comes over to here. After 10 minutes has gone by, right, through the timer, it comes up and initiates a time defrost, but it also needs to initiate, there's my input, it needs to initiate the next timer. So we'll say this is set on 10 minutes, and we're going to say this is going to be set on 1 minute. So the moment we get 24 volts here, to initiate a defrost after 10 minutes of Y without O, okay, then the next timer will stand by for 1 minute. It'll let all this happen for 1 minute. Then we'll have power here after a minute. Well, what we're going to do is we're going to energize this relay, okay. I'm going to go ahead and run common, back up, okay. And what will happen here is we need to send power back over here. So we can just take that same Y call, we're using Y for everything here, because we only need this to happen while the thermostat is wanting something to happen. All right, and we can take out of that Y call, we can land power back up here on terminal 1. All right, so using our cool voltage, give contact voltage on 1, and then what can happen is when we have 24 volts here, we'll have power, we'll have that 24 volts now over here, and then what we can do is we can come up and land power right here on this relay, which does the same thing that this does when it's in cool. It cancels all that out. And that's pretty neat. So that means even in a forced defrost, okay, there will be backfed voltage back to this point, even on forced defrost, because through here, when there's no O, right, 24 volts, if this closes on the sensor, there's 24 here, there's 24 here, so defrost is happening, but we're backfeeding voltage all the way back to this point, which also still sets a timer. So now we know that even in forced defrost, we're never going to run more than a 1-minute defrost cycle. Now let's just say that if a minute is not long enough, then that means the sensor is still closed. So what happens if the sensor has not been opened after a minute, then it'll time out and then start it all back over again, right, and give it another minute. This is a safer way to ensure that while that fan motor is off and there's hot gas running through that coil, because it's theoretically in cool mode, we don't have too high of a head pressure, right? And so this is a lot. And we are not suggesting that anybody take out a board and try to be a hero and make this happen. But what we want to do for educational purposes is we want to take this passion that we have of teaching our industry. All right, we love this industry, and we want to make sure that that next generation or this generation or even the past generation who has not clearly understood relays, take the most expressed way of making something complicated, dumb it down, make it easy, and then when you go back to that one thing that you thought was complicated because of a board that had a lot of things going on with it, you're now going to look at it a lot easier and say, hey, you know what, that's not that bad, plug and play. And so I hope that winding off these defrost controlled videos, I hope we have made this understanding defrost and understanding the different boards out there, I hope we have given you an appreciation for those and what these manufacturers have done for you. And we hope that they are now easier for you to understand, and also understand that this is where it started from. All right, this takes up a lot of room in a corner panel, and a defrost board's a lot smaller. It's a lot cheaper to produce. It's a lot less parts to go bad. It's easier to diagnose, because now here you'd have to, if something wasn't right, you have to really know your relays to find out, well, what relay's not working properly? What timer's not working properly? And I hope this helps you out. As I always say, like our channel by subscribing, like our videos, put a comment in the box. We love that. Share this with others, and all that supports the algorithm so we can continue to grow and be in front of new people that need to know this stuff, that love this stuff. Thanks.